right, where we left off here, angle bisectors. We talked about where all three of these angle bisectors meet. This is called our incenter. And our incenter will always be inside the triangle. But one characteristic we want to take away is that the incenter is equidistant away from the sides of the triangle. So kind of like vice versa over here. The perpendicular bisectors were equidistant from the vertices or the angles, where here the angle bisectors, where they all meet, this is going to be our incenter, and the incenter is equidistant from the side. So it's kind of vice versa there. Anyhow, let's flip to the back of our notes. There we go. All right, so the median, typically in terms, when we talk about median, we're driving and it's the middle part of the road, the median. So the median's in the middle. Here, our median in a triangle is the segment from the vertex of a triangle to the midpoint of the opposite side. So you can see line segment BD here is our median, goes from the vertex and then to the midpoint of the opposite side. We're going to practice finding where all three of these cross here today. So when we get to that, we then find the centroid. The centroid is where all three of these medians intersect. This point, again, is always going to lie inside the triangle. And lastly, a good characteristic to take away from here, I know this kind of looks funny, this 2/3, 2/3, 2/3. So I'm going to put it in just math terms here. So what we want to take away is that the centroid, if you have a line, so say that our line here, we have FR. Say FR equals, just pick a number, 4. Then from R to B, so then RB, that is going to be twice as much. So twice 4 would be 8. So this segment's 8, that segment's 4, together they're 12. And that's where you can see, oh, this is going to be 1/3, this is going to be 2/3. And together they make the whole thing 3/3. So that's what you want to kind of take away from a centroid, is if they give you one side of it, the other side's going to be twice as much, or the other way around, be half of it. So boom, write that down. And lastly, our altitude, the altitude, and that's our height. Okay, and the height is measured, excuse me, as a perpendicular segment from the vertex here, and it goes straight up and down. So you can kind of see that vertical line here and makes that perpendicular side, and on the opposite side there, giving you that right angle. So bing, bada, boom. What do we know about when we have three altitudes? And usually, we only see one altitude, but if we turn the triangle, well, boom, there you can see the altitude coming from angle A, and then also we see our altitude coming from angle C. So depending on how you kind of look at the triangle, you can have multiple altitudes. But anyhow, if we kind of twist it around and we do an altitude from each angle, this is called the orthocenter. The orthocenter is the name where they all intersect, and this will be inside the triangle. This is what it says for this one, for acute, okay? Acute will be inside, because this is going to be kind of similar to our first vocabulary word, which was the circumcenter, where acute is inside. But if we have, we'll focus on this one here, obtuse, the obtuse triangles are going to be, the orthocenter is outside. And here's point R is where the orthocenter meet, or the three altitudes meet here. And I just wanted to highlight the actual triangle that we started with here. So you can see, because it looks like, what the heck, that these are kind of all jumping off of there. So there we go. There's that one. And so obtuse outside, and then the last one, our right triangle, is going to be on the right angle. So here you can see there's our altitude. And then if we did an altitude from any of the other ones, they would kind of just all go straight up and down, because it's that right angle, or that right triangle. It's, pretty perpendicular there on the side. So you end up, your orthocenter is going to be point R there. So there's our notes today. We're going to get some practice